Hello, Shasta High School Honors Math 1. This is Mr. Roberts, and this is a quick look at the study team test for Chapter 3. Um, First question, by the way, this video is just question 1 only, right? This will be part of a playlist that will contain all the questions in the study team test. On question 1, it says simplify and that your answer may not contain negative exponents. Remember, to simplify means to reduce the number of operations needed to evaluate a particular expression. And we've been looking at techniques to do this sort of thing actually since the beginning of the year. And I think what I probably should do is I'm just going to move over and display the law of exponents. And you might want to copy those down. You can definitely look them up in your book. If you look up laws of exponents, you'll see them all there. But let me just display them real quickly here. So these are actually, there's a few more than the ones that are contained in our book. But I think if you look at them, most of them make sense, and most of them are things that we definitely have looked at and things that you can use. Um, for example, if you have, the bases are the same. If I have like 3 to the second power times 3 to the fifth, we understand that they're all threes, factors of threes. And how many of them do I have? I have a total of 7 of them. So that's 3 to the 2 plus 5 power, or 3 to the seventh. There are 7 factors of 3. A couple of these are ones that we don't necessarily have. Like, for example, this one I don't think appeared in our book, but it does say that if I was multiplying something like, I'll do a 2x squared y, and I'm raising this to the third power, one of the things I can do is just use the definition of exponentiation. And if I did that, I could write out just by definition there are exactly 3 of these things. And what are the things? They're all 2x squared y, 2x squared y, and then a final 2x squared y. And if you look at this, right, part of it is that there's 1, 2, 3 factors of 3, right? That's not surprising because that's what that was. There's also an x squared, another x squared, and another x squared. So I've got a total of 6 factors of x. And the other thing that I see here is that there's a y and a y and a y. So what this rule says, this law of exponents says, is that you can rewrite this as 2 to the third power, right? 2 times 2 times 2 times x to the sixth power. And that's kind of combining this law with this law also, right? So x to the sixth power, and then finally times y to the third power. So just writing it all out. So anyways, if these laws are something that you're struggling with, working with, you might want to jot those down, and then find practice. Just practice, write them down, get comfortable about them. Think about what they're saying in the context of integers that you can understand, and then just test things out and make sure that in your mind it's clear how things are working. So let's go back over to the problems that occurred in our test. The first one, interestingly enough, is there are 3 factors of 3x to the negative second. So I could do it 2 ways. I can do it using that law that we just looked at, but probably the thing that I would prefer to do is just write out using the definition. I have exactly 3 factors of 3x to the negative second. So I'm just going to write it out, right? There's 3x to the negative second times another 3x to the negative second. And then finally, there's one more copy of 3x to the negative second. I'm sorry that keyboard keeps popping up. I got to figure that out. So if I look at this, I've got 1, 2, 3 factors of 3. It's all multiplication. 3 times 3 is 9, times 3 is 27. So there's a 27 here. And I also have x to the negative second, x to the negative second, x to the negative second, which is x to the negative sixth power, right? So the other thing that's happening here is it does say in the directions, right? Simplify, right? Reduce the number of operations needed to evaluate, but also don't leave any negative exponents in your answers. So I'm going to get rid of this negative exponent I'm going to just choose to multiply it by the number 1 in the form of x to the sixth over x to the sixth power. And when I do that, the thing that happens in my numerator is I end up getting x to the negative 6 times x to the sixth. And x to the negative 6 times x to the 6 is x to the 0 power. And that's beautiful because x to the 0 power is just the number 1. So across my numerator, all I see is the number 27 and then multiplied by 1. So my numerator is just now simply the number 27. And in my denominator, I have the expression rather, x to the 6 power. So this is the answer we're looking for. No negative exponents, and we definitely reduce the number of operations needed from, like, what is it, 1, 2, 3, to essentially just 2 operations. Not a lot of reduction, but some. So let's move on to question B. On B, right, one of the things I see right away is there is this negative exponent, and I want to clean that up first. And this is just kind of me. I like to get rid of these. The sooner the better. So I'm going to multiply both the numerator and denominator by a to the 5th power. Again, I'm allowed to do that because anytime I multiply by the number 1, I'm not changing this fraction that I start with, right? I just have something times 1, so it's the same thing. The reason why I selected a to the 5th power is because in my denominator, I can see I've got a to the negative 5th times a to the 5th, which is again a to the 0 power, which equals 1. So happy day. In my denominator, I just have the number 15. In my numerator, I now have 5, and I also have a to the, it was a first, and then I've got 5 more factors of a, so there's a total of 6 factors of a. So 5 times a to the 6th over 15. The final thing I'm going to do is very explicitly point out the giant one that's lurking here, right? In my numerator, I've got 5 times a to the 6th. In my denominator, I'm going to write this as 5 times 3, which is 15. And I do that just so that it can be very clear that there is a common factor, a giant one of 5 over 5. And I can eliminate that, and our final answer then is just going to be a to the 6th power all over the number 3. A to the 6th over 3. All right, let's move on to part C. On part C, interesting, I think because we were doing multiplication of binomials, some of us looked at this and said to themselves, oh, these are binomials, and they're not, right? This is a monomial times a monomial, so the answer will be a monomial. There's no addition, subtraction here. There's not multiple terms. It's just the one term. And I can reorder multiplication problems because of the commutative property, right? I think we all understand that 2 times 6, right, is 12, which is the same thing as 6 times 2, which is also 12. So because of that property and multiplication, right, I can go ahead and reorder this. And I think I'm just going to make it as 4 times a 3. So I reordered those two, and then I'm just going to multiply it by x to the 2nd times x to the 5th power. So if I look across, right, what I have is 4 times 3, which is clearly 12. And then I have 2 factors of x and then 5 additional factors of x. So that's a total of 7 factors of x, right? So 12 times x to the 7th power. And then finally, on question D, you can see in my denominator I have a something that's being squared, and I probably should look at and figure out exactly what that is first. I do know that it's a 2 squared times x to the 4th, and then that part's getting squared, but I'm just going to choose to use the definition of exponentiation and write out that base, right? It's going to be 2x to the 4th, and I have 2 of those, so I'll write another 2x to the 4th power. In my numerator, I'll just go ahead and rewrite the fact that I have x to the 7th, or 7 factors of x. Now, in that denominator, right, again, this is the commutative property, I end up getting 2 times 2, which is 4, and then I have x to the 4th, which is x to the 8th power. There are 8 factors of x. And again, I still have x to the 7th up in the numerator. Final thing I want to do is just very carefully show you that there is a giant one, and I want to spell out exactly what it is. In my numerator, I've got x to the 7th power. In the denominator, I'm going to write 4 times x to the 7th power. So I'm just spelling out that I can break up these 8 factors of x as a single factor of x and then 7 more factors of x. So it's very clear that I have exactly 8 factors. I didn't change my denominator. And you can see that this now does clearly have a giant one, right? A common factor of x to the 7th power in both the numerator and denominator. So what I'm left with is, in the numerator, there's nothing but the number 1, and in my denominator, I've got a 4x. So the answer to D was 1 over 4x. Okay, so we can see our final four answers. A was 27 over x to the sixth. B was a to the 6 over 3. C was 12 times x to the seventh power. And D is 1 over 4x.